This hit and run is on writing the sentence and the magic paragraph, so named by a former econometrics student here at James Madison University. And the analogy, I'm just going to go quickly through this. Keep close to the pause button because some of you wanted a quick go through. We'll spend much more time on this in class. Remember that it's like paint by numbers. There's the beautiful Mona Lisa by Leonardo da Vinci. But wait, look closer. No, it's not the original. It's been painted by numbers, meaning that there was this numbered canvas that was pre printed there, and the artist would just put color number 22 where it went and color number 16 where it went, and the result would be this painting. Nobody thinks you can turn into Leonardo da Vinci by painting by numbers, but hey, you can learn about handling a brush, about how paint goes onto canvas, about how a great artist achieved some of the color effects that are in here. And in a similar fashion, this is like paint by numbers for econometrics. Here is the business school salary and tuition and student faculty ratio study that was done. Won't go into detail into it now, but we'll just point out that the starting salary of business school graduates was related to the tuition that they paid and the student to faculty ratio at the school they attended. And what it results in is this, the magic paragraph, which I won't read to you right now, but it is a paragraph reporting the regression results, taking those numbers and providing an interpretation so that you can figure what they really mean. Well, now what we want to do is go through that magic paragraph just sentence by sentence, seeing exactly what it says and how we do it. We start off with a topic sentence summarizing the results. Now, right here, these regression results suggest a relationship among tuition, student faculty ratio, and starting salaries for graduates of 57 business schools. It sets the scene here, and you notice that it uses some language very carefully. It doesn't say anything causes anything, it doesn't say anything is proven, it says it suggests it. And now, here we have the sentence. Remember that learning to write the sentence is the single most important skill that you get out of a basic econometrics class. Interpretation of each statistically significant regression coefficient with correct units. So what we're saying is for this sample. Notice that? We're not saying for the whole world. We're just saying here's what we found in our sample. An increase of $1 in tuition. This is so important. You've got to start with the explanatory variable. If you start with the explanatory variable and go to the dependent variable, then you will get it right. If you reverse it, you'll get it wrong. This model envisions that changes in tuition are associated with those changes in starting salary for the reasons that we talked about. Notice again, there's no causality, it's just was associated with. Notice also that that is the explanatory variable in its correct unit. It's $1 in tuition, associated with an additional 18 cents of starting salary. Go get that number from the printout. 18 cents of starting salary. It's 0.18. And then holding the student faculty ratio constant. If you've just got one other variable in the regression, then you do go on and say what it is. If you've got one or two more, then you say what they are. But if you've got a whole bunch of things you're holding constant, then you're allowed to just say other things equal. Yeah, it's a time saver. Okay, then the statistical significance and the p-value for each statistically significant coefficient. The coefficient on the tuition variable was highly statistically significant, and now we put the p right there. In this case, 0.0003. There's not any definite convention on exactly how many digits you report, and I would say just be sensitive to context and always do what your next econometrics professor says. Always do what a journal editor says. Then a brief mention of coefficients that are not statistically significant. In this equation, we didn't have any, but here's an example. The percentage of students associated with Greek letter organizations, fraternities, and sororities had no statistically significant effect in this model. If we had a Greek variable and it turned out to have a p-value that was too high, then that's what we would say, something like that. Again, in this model, there wasn't one there, but I wanted to show you the example. Then we have a brief commentary on the overall fit of the equation. The regression as a whole fit fairly well for a cross section, and they report the r squared and the adjusted r squared. Again, there is no particular convention, but it's often rounded to three decimal places there. And notice here that we are talking about the regression as a whole. That's not any one coefficient, it's how the regression as a whole fit. But to do the formal hypothesis test on the regression's fit, we have to go to the F test and was highly statistically significant. And in this case, F was 19.63 and the p-value was less than 0.0001. Notice that the F number doesn't really mean anything all by itself. So if your professor or a journal editor says, hey, you really ought to put the F in there and then put a comma and the p-value, then you do it, just recognizing that that F value doesn't have any meaning by itself. Then check that you didn't paste in any wording inapplicable to your results. See, I know that you might be inclined, just to make sure that you covered everything, to go ahead and paste in this entire paragraph and then go change it to reflect the variables that you're working on. That's fine, but if you're doing a Phillips curve on inflation and unemployment, there better not be anything about business school tuition in there. So don't paste in any wording inapplicable to your results. Check that you capitalize correctly, especially r squared. This is a big deal, statisticians. Little r is the correlation coefficient. Make it r squared. And make that a true superscript. You know how to do that. Don't just make it r2. And that you didn't use the word correlation unless you meant the correlation coefficient r between two variables. And I do have a bonus question for this. What happens to your results when you include the average SAT score as an additional explanatory variable? Yeah, that's a good thing to do. And the data set is out there somewhere. Okay, so that's the way that we write the sentence and the magic paragraph. Now, there are a few notes on this whole process. And one of this is just a reference to your textbook. For a discussion on the use of p-values and regression reporting, go have a look at the book. Informal equivalency, statistically significant, is a p-value less than or equal to 0.05, highly statistically significant, less than 0.01, and then just not statistically significant, greater than 0.05. Now, what happens if you just miss statistical significance? No consensus. Now, in some subfields of economics, any p-value over 0.05, no matter how close, you just say not statistically significant. Hey, these time series people that are used to getting F numbers way up in the thousands and tiny p-values, hey, if it's over 0.05, forget it. In other subfields, researchers will informally note that it came close. They will not call it statistically significant. They'll just say it was close to statistical significance or something like that. Now, in still other fields, p-values, here's a cutoff of 0.10. And this would be especially true in behavioral science, psychology, sociology, and within economics, public choice, and political economy. There, they'll just refer them to these as marginally statistically significant or even just statistically significant, and then they'll document the p-values in the tables, and that's where they fess up. Oh, you know, it didn't quite hit 0.05, but hey, it was 0.8, so 0.08, so it was almost statistically significant. And then don't just mimic the language fairly well for all the r squared values that report. Pay attention, get some context, some guidelines. Time series work tends to produce higher r squared values than cross-section work. So if you get an r squared in cross-section above 0.04, 0.05, hey, that's considered strong. Time series data may exaggerate r squared values, so don't get all excited about an r squared above 0.9. We will have a look at some distinctive time series problems later in the semester, and I'll just say that time series is so distinctive as a method of analysis that it does deserve its own course, and it gets its own course, and I highly recommend that to those of you that are going on. So that is the magic sentence and the magic paragraph. It's what happens when we take just raw statistical results like this, and we end up telling a story. Again, the single most important skill you can take from this class, that is a hit and run on writing the sentence.